Hello all, welcome back to the tutorial session on the topic performance measure of classification in machine learning algorithm. And in this session we are going to discuss about the topic recall, F1 score and area under the ROC curve. So what is in by recall? So recall is the ratio of correct positive prediction to the overall number of positive examples. So in mathematical way, if you can define recall means it is true positive to the ratio of true positive plus false negative. In continuation of previous example, we can see what is meant by F1 score. The F1 score is the formula for the standard F1 score is the harmonic mean of precision and recall. So in mathematical way, we can define F1 which is equal to 2 into precision into recall divided by precision plus recall, or F1 which is equal to TP divided by TP plus half the rate of FP plus Fn. So we can consider this example. So this may vary. For example, you have COVID. It's an example related to biomedical. Actually you have COVID, but your model predicts it as COVID. Okay, fine, it's good. It's perfect model. Actually you have COVID and your model predicted it as no COVID. So it's a case 1 type 1 error. So this is not a correct way your model should predict. And the third case, you don't have no COVID, but model predicted this as COVID. Somewhat it is accepted, but it is false. And you have no COVID, and your model predicts this also, you don't have COVID. So it is a perfect model. It is important in medical cases whether it does not matter whether we raise a false alarm, but the actual positive case should not go undetected. For this example, type 1 error should not go undetected. Same way we can have the cancer example too. Diagnosis of cancer. This is also related to medical cases. Actually you don't have cancer, but your model predicted as cancer. Yes, perfect. Answer is right. Actually you don't have cancer. Actually you have cancer, but your model predicts as no cancer. It is a tedious one. It not happen. And third case, you don't have cancer. Model predicted as cancer. But in that case, we need to go for one more test. And fourth case, actually you don't have cancer, and model predicted is also you don't have cancer. So it's a perfect model. So I want you people to work out on this, and what is the example, what is the answer for this particular example for precision, recall and F1 score based on the part 1 video. So can you define accuracy? Accuracy is nothing but your true positive cases that comes under the diagonals and true negative cases divided by the whole number of cases. False true positive, true negative, false positive and false negative. Same way in multi-class classification you could able to define with the same example. You can say what is meant by recall, and same way you can go with precision too. And most importantly, some many places we need to fail to highlight this rejection rate. How much percentage your algorithm failed to detect a particular character. For example, you are giving input as A and model predicted this as A. For example, you are giving this A and this A, and few have like this is also an A. Fine, but unknowingly in your model you have given like this. Fine, this type of errors, this type of characters will be rejected by your model. That ratio also need to be calculated. Fine, that will happen in multi-class classification. So in multi-class classification example, if you see, so diagonal matrices are correctly predicted on true positive, but these are false negative and false negative, false positive and false negative. See here, this if you have this accuracy comes over here 0.89, it is 137 divided by the total row values. 137 divided by the total row values, you will get 0.89. Same way, how this 0.86 comes, it is 55 divided by the total row values. So here in this case is 57 plus 58 64. 64 55 divided by 64 you will get 0.86. This is how you need to calculate the accuracy of individual rows. So what's meant by area under the curve? ROC curve. So ROC normally stands for receiver operating characteristics. It is the expansion of ROC. Mostly it is used in radar engineering. By the year of 1941 they have used this type of technology in military radars. So ROC curves is a combination of two things. One is true positive rate, another one is false positive rate. What is meant by true positive rate? True positive rate is the proportion of positive examples predicted correctly, defined exactly as recall. Its other name of true positive rate is we can call it as recall 2. But false positive rate, it should be actually less and true positive rate should be actually high. But in that case, true positive rate, F1 is very costliest one, we need to reduce that one. So false positive rate, the proportion of negative examples predicted incorrectly, right? So to build up a summary picture of a classification performance, we can have false positive rate. And in addition to the TPR and FPR, we can see what's in by specificity. Specificity is nothing but 1 minus FPR. In mathematical expression, you can call it as Tn divided by Tn plus FP. Fine. Sensitivity by ratio of sensitivity by recall, you can call it as TPR. So it's a typical way of representing your TPR and FPR in graph. And the area under the ROC curve, AUC curve, it is to compare different classifiers. You can see here you have a number of classifiers. In this diagram we have mentioned it's a perfect classifier and it is okay, and this is better, and it is a random classifier. Right? This is to summarize the performance of each classifier into a single measure. One common approach is to calculate the area under the ROC curve, which is abbreviated to area under the curve, AUC. So AUC ranges normally from 0 to 1. A model whose predictions are 100% wrong, by that time your AUC value will be 0 for wrong case. Once your predictions are 100% correct, by that time your AUC value, area under the curve value, will be equal to 1. So AUC is classification, threshold, invariant and suitable for comparisons. So for case 1, I want you people, you have in this case I have given you 4 cases. I want you people to try on your own and give the answer in comment box below. For spam, actually the spam value is 10 and your prediction model is also 10. But actually spam value is 0 but prediction value is 0. Same way for not spam and spam it's 10 and not spam and not spam it is 0. For this particular case, I request people to calculate your TPR and FPR and point where your ROC curve will be. Either it is 0, 0, 0, 1, 1, 0 or 0.5, 0.5. Suppose if you are getting a 0, 1, here it is 0 and 1. Here you will get 0, 1. If it is 1, 0, here it is. If it is 1, 1, here it is, you will get here if it is 1, 1. So which model you can say it's a best model? So the point where you are getting over here, it's a best model. Area under the curve will be good. I want you people to calculate for case 1 and this is for case 2 and for case 3. Here for this example you can say it's a best area under the curve, you will get actually 1. So where you will get 1, you will get 0, 1 here. You can say this is a best accuracy or best area under the curve. And I want you people to try for this case. If you try, you will get 0.5, 0.5. Right? Thank you. We'll meet you in another video.